Okay, in this video we're going to complete lab 3. So I'll go back. So we've done the Euler method and now Heinz method. So Heinz method should average 2 slopes. So here's one slope, that's the previous slope, and then the predicted next slope. The predicted next slope, it depends on V, it should use the predicted V, which is in C3. So replace this V, this previous V, with the predicted next V. Replace this V with the predicted next V. And that's us in money. And this is more accurate than Euler's method. The predictor is just something we're using to help us calculate. So in terms of output that we're interested in, we're just actually interested in the velocity. Okay. So the terminal velocity. So if you multiply both sides of this by m, we get m by dv dt. dv dt is the rate of change of velocity, otherwise known as acceleration. So mg minus m times this is the force, and terminal velocity is when the gravity force is balanced by the drag, so that these two are equal to each other with the m's. And you can divide out the m again. So if you solve this equal to this, you will get this this terminal velocity. I'm supposed to go a bit further. You get this 62.4. That's that. So this is the kind of thing we're looking for. Okay. Now in terms of the VBA, so minimize this and follow the instructions. One moment though. So what do the instructions say? So the developer view code. There, yeah. So okay, define the variables. Dim x as double, dim t as double. They are most important. They come from the. I'm in the wrong sheet. Here we go. So it's dv dt. So v and t are the most important variables. Then we're doing Heinz method. We need this predictor. So dim vp as double. Dim h, our step size, as double, coming from the worksheet. Dim t final as double, the final time. Dim c as double, that's the drag coefficient. Dim m as double, that's the mass of the object. Dim r as integer. I've been doing integer, and it's been okay, but that only goes up to 32,000. It's working for us most of the time. I might just point out that you could use it long. So someone in the past actually told me this. So if you like, Excel can take 1,000,000 rows, I think, something like that. So you can have more than 32,000. If you integer only goes up to 32,000, long goes further. Okay, initial values. V is equal to cells 2, row 2. This looks like column 8 is where I have that. Notice there's no V0 variable. V is a variable, it has an initial value of V of 0. T is equal to 0. V predictor is unique, it has no, in the sense it has no initial value. H equals cells 2, 4. TF is equal to cells 2, 5. C is equal to cells 2, 6. M equals cells 2, 7. Or the row number starts at 2. So the printing looks like cells, whatever row you're in, column 1 equal to T, cells, whatever row you're in, column 2 equal to V. That's that printing done. And then the next values. So the time just ticks, time equal to T plus H. The predictor, so if we looked at the predictor, we might even go into the formula here. The predictor is not the previous predictor, but the previous y value. That would be just your v plus your h times your derivative. So v predictor is equal to previous v plus step size times slope. Slope 9.81 minus c over m. Now you might be worried about m, that's so you can put a bracket around them, times v times the absolute value of v. Okay, that's good. And then Heinz method for v. says next v is equal to previous v plus step size times. Let's go back and have a look at Heinz method. You're averaging two slopes, the previous slope and the predicted next slope. Dividing by 2 averages those. So we're going to have two slopes divided by 2. So the previous slope looks like this. And then the predicted next slope, you replace the v with vp. Let's calculate v up to counter r equal to r plus 1, and you loop until the condition. So we want to keep on going until maybe the time is bigger than the final time plus h, or just bigger than that will work as well. So that's that pretty much all done. Shut this down, run the program, hopefully everything is all right. Oh boy. So I'm scanning this. M is 225, C is 90. Idiot features here is messed up C and M. So see the way I got the error? I can hover over, I can see I made the mistake. Yeah, actually I messed them up there. So that was a very, very large damping coefficient, a very, very light mass, so massive forces, which is causing massive changes in slope and even massive changes in every derivative, and it's a nightmare. That made no sense. You'd have to make a really small step size, I think, to handle this at all. I'll just give it a bash. So this is just me being stuck. It's hard to see that. It's not even handling it with that step size. Oh boy. No, it is. It's a lot of rows, 20,000 rows in a second. You saw we got nonsense, so we need a step size. Now the errors in Heinz method are a lot smaller, so the improvements that we can get from making the step size smaller are great, but this is still 20,000 rows. And because the Heinz method has 2 calculations in it, the predictor, it's 40,000 calculations as such. I might have to interrupt this, to be honest, there's too many rows. Oh, I got there. Now this, well, we'll just see what happens. Yeah, it's just there's an awful lot of data points there. In any case, that's not really what we wanted, especially since I changed it back the other way around. What was that? It's going to go 0.01 this time. Now I've got an issue where I have old data. So remember, I should do the macro recorder. So you're going to see the old data. See that? So again, just to remind you, the macro recorder, developer, record macro, macro 1. I'm going to select columns A and B, delete, put in my T, put in my V, stop recording. That was called call macro 1. So I'm going to chuck that up there. We'll get rid of that, and I can do this. Okay, that's still a fairly small step size with this really weird situation, but actually what we want, 0.225, 90, step size of 0.2. I've got the macro recorder, so things will work nicely. These are the same numbers we saw previously. Okay, that's Heinz method done there. And then this exercise. Now there's a bit of scope to do different things here because there's mathematical issues in this. Let's get cracking. This is the exercise. We did up to 8. Now the additional functionality we won't bother with. Okay, so this exercise here. So dx dt. So x is like my y and t is like my x. Okay, dim the predictor. Whoop. Dim the predictor as double. Dim the step size as double. Dim the final time as double. And dim a little r as double, dim big R as double, dim RW as row counter as integer. Integer or long, as we said. Initial values. X is coming from my dashboard. Have we even got a dashboard set up? Okay, so let's say 1, 3.5, final time, let's say 25, step size of 0.1. Right. So where are we going? X is equal to cells to H is the 8th letter of the alphabet. T, we're going to start at 0. XP has no initial value. H equals cells. Row 2, H is in the 4th letter of the alphabet. TF equals cells to 5th letter of the alphabet. Little or equals cells. Option explicit is great here if you were to spell littler and misspell one of these. What am I looking at? Little r cells to 6. Big R equals cells to 7. Or W, we're going to start at 2. Okay, the do loop. Print the current value. We want to print cells row column 1 equal to time, cells row 2 equal to X. That's the printing done. Shouldn't leave that. Calculate next value. So the next T just goes up by tick, 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 tock. The X predictor. So the predictor is equal to not the previous predictor. It's not exactly Euler's method. The previous X plus the step size times the slope. We have to get the slope from the differential equation. Minus 2.658 times little r squared. Sometimes it doesn't like this, so you have to put a space around it. It's kind of annoying. If it doesn't like that, you can do little r by little r. Divided by big R squared, that should be okay, times square root is SQR, which is a bit weird. X, okay. X now is a similar story, except, well, it's Heinz method. X equals previous X plus step size, and now we're going to average two slopes. We're going to do the previous slope, which is this, plus the predicted next slope, which we'll use not X but X predictor. We're going to be aware of this. Come back to that. Calculate X, we've done that. Yeah. Okay. And then up to counter. And then loop until condition. I think loop until the time is bigger than the final time. Maybe plus H. Now, there are issues with, if you run this, it might work. We'll give it a go. Or it might give us errors. Errors. Variable not defined. Excellent. That's what option explicit is for. That would have crashed. We go again. Oh, I have to stop my code. We go again. Debug. Now never press enter, press debug. This is telling you that something is wrong. So it felt like an argument was an issue. That argument is something you put into a function. Something being wrong would be like division by 0 or square root of a negative. Have I messed up my big R and put in? No. Is there something inside the square root? Come on. The X has gone negative. So this tells me that there is a mistake here. And over that, I can see another mistake here. That should be plus. But anyway, the X going negative was an issue. So if the X goes negative, the tank is empty. The height can't go negative. So you can do a little if here. If X is negative, then reset the X to be 0. That's a good idea because it's like that means it's empty. We'll see what happens now. Give it a bash. Okay, this looks pretty good. You can get other errors here. So let's see this. If we get a bigger time, we'll see what we did with resetting the X to be negative. Oh, a different issue. Debug. So there's something wrong here. It's not the division by 0. Oh, the predictor has gone negative. Now, if the predictor has gone negative, that should be also. If the predictor is negative, then it's predicting that it's empty equal to 0. There is another option here that if it's empty, maybe you exit sub. In other words, just finish. But actually, it's nice to see it going completely empty here. we should see, I just need a new graph, I think. Yeah, you can see it going empty like that. Okay, so dealing with that is probably a little bit harder, and I'll give you an assessment. To have an idea of what's going on in the assessment, you can have a read through these. So, quick video. Hope the beauty is we've got pause and rewind, and hopefully I spoke clearly. Okay, thank you very much. Good luck.